I've never gone to Disney so worried. I mean, I'd probably die, but I've just never gone. You're gonna go. You're gonna go. It was like that one. It was like that spring break. It was just too warm.
Alright, guys, we're gonna start with the problems for Friday. There's 6 problems, we're gonna run through them real quickly. Then Mark and Catherine
Big 6.
I'm just gonna go one at a time, we're not going back and forth. Anything on number 1? Alright, some of you are trying to force inverse trig derivatives onto this. Alright, doesn't work. Okay, if it doesn't work, doesn't work. Dead end, you're gonna realize. None of the trig derivatives have a square root of x squared plus 1 in them anyway. It's square root of x squared minus 1 and square root of 1 minus x squared. Alright, number 2, again, just because you haven't seen something doesn't mean it's not a thing. ln of the absolute value of the ln of x plus c. But those absolute values better be there. Alright, we went over that. We have a page of notes about why you need the absolute values. Alright, 1 over x is the derivative of the ln of x. Fill in the blank sentence works well for these problems. Alright, number 3, 1 divided by 1 plus x squared is the derivative of inverse tangent of x. Alright, if you want to do this first, this is fine. Constant multiple rule on the 4. It's going to have to get dealt with sooner or later. You're going to use the constant multiple rule on it here or there. Okay, I was having a conversation with Eunice, I think, about this. Remember that -1 is not an exponent. That's a notation for the inverse. We don't use negative exponents with trig functions, so that cannot be written like tan to the -2 of x. That's not legitimate mathematics because that -1 is not an exponent. So, well, it looks like an exponent. We understand context, and the context of this is that we don't use negative exponents with trig functions. Right? That's notation for the inverse. All right, anything on 3? All right, now some of you were struggling and you self-identify, like, no, I don't know my derivatives as well as I should. You know, Harry went and he owned that one. He said, yeah, the problem that we did to start class, he said, you know, I realized I should go back and learn my differentiation rules a little bit better than I do. Helped? Learn from our transgressions, right? Okay. One of the mistakes that came up here, people not having negative signs. Or you gotta, oh, I was close. You know, free response question, you're gonna get away with it. Multiple choice question, you're gonna be in a lot of trouble. Okay? Cosecant squared of x is close enough to being the derivative of cotangent of x. All right. If it helps you to rewrite it like this is something I do with beginners who are struggling to see the value of u. Because if you say, oh, I let u equal cotangent cubed of x, that's going to turn into a mess. So if you realize something that's getting into a mess, stop yourself and say, maybe I don't have the right choice for you. Go back and see if there's something else, instead of trying to force something. I mean, we don't force things here. All right, anything on 4? 5, this is set up very well. Secant squared of x is the derivative of tangent of x. All right, notice in none of these problems have we said anything about rewriting in terms of sine and cosine. All right, you get u du, so the antiderivative of u du is 1/2 u squared plus c. Anything on 5? All right, 6. Okay, u is cotangent of x, du is the opposite of cosecant squared of x dx. All right, I think we had some problems here maybe with some exponents when we were anti-differentiating, if I remember correctly from Friday. All right, just be careful with those little things. Alright, you might see it as cotangent to the 3/2 of x. This would be a matter of making your answer like this. You might see it like
It's the
that.
same
Hmm?
thing. It's the same thing.
Same thing.
Okay.
It would just be a matter of matching multiple choice answers. This wouldn't be a free response question. Alright, number 7, if you need to rewrite it like this on the right, go ahead and do that. If you don't, then you don't, okay? Some of you, when you get stuck, I notice that you're sparingly writing out the fill in the blank sentence. We talked about going back to what you're comfortable with if you need to.
One trick.
Yes. Alright, sometimes writing in extraneous parentheses helps you see. But if you don't know your differentiation rules, see, I look at this and I say, secant of u, tangent of u. I know how to anti-differentiate that. So then I say, oh, u equals 8x. But if you don't know your differentiation rules, you can't, remember we said you can't recognize something you don't know. Alright, it's not going to jump out at you. The better you know your trig differentiation rules for this problem, your differentiation rules in general, for these problems, this type of problem, the easier these problems are to get through. U has to be 8x here. Anything else isn't going to work. Are you all right? Grilling my work pretty hard.
I'm looking. There's work there.
It's all good?
Yes, but I can see it. Yes, you do.
Circumlocution. Did that word ever come up on the SATs?
Again, we don't. Our SATs aren't a thing anymore, Mr. Dago. We don't do the essay anymore. It's an antiquated testing procedure. Bad.
All right. Are you good? You all right? Anybody else? 1 through 8 questions. Okay, just want to talk about some dead end stuff. Some problems that I did already, and I'll post these. Sometimes you get a true statement that doesn't work. So if you have cosine cubed of x times sine of x, and you say, well, cosine of x is close enough to being the derivative of sine of x, that's a true statement. But you can't make that substitution work, because here we have cosine cubed of x dx, and here we have cosine of x dx. And people are like, oh, well, can we cube both sides of the equation? First off, that's not an allowable operation, but you can't selectively cube, because if you cube both sides, you're going to get du cubed, you're going to get dx cubed also. The only thing we're allowed to do to both sides of this equation is multiply by a constant, okay? So the reason you can't do it that way is because this is really this, and you want to see those layers of the composition. Okay, so you can't force something. You're like, well, cosine of x is the derivative of sine of x. It is, but that doesn't get you through this problem, making u equal to sine of x. U has to be equal to cosine of x. Very few and far between are the problems where you have more than one choice for u. Understand that. Okay, that most roads are a dead end. So here, when I reversed them, I got through the problem all right. The other way was a dead end. Okay? Now, this came up before I had any prompting with it on Friday. What should we never let u equal, ever, in integration by substitution? U never equals x, because it doesn't change the fundamental issue. You just have the same problem, but it's got u's instead of x's. All right? The change of variables is supposed to make it easier to anti-differentiate, that it removes a product, or the quotient, or the composition, or some combination thereof. Okay? All right, u equals x, pointless. Okay, if you say something like this, because I had somebody, sine of x is close enough to being the derivative of cosine cubed of x. It's not even a true statement. Okay, so if you start with a false statement for your fill in the blanks, and then you wonder why the substitution won't work, Well, there you have it. You can't base anything on a false assumption. All right, so be careful with that. Something like this. X is close enough to being the derivative of x squared. People say, oh no, sine of x squared. But if you start differentiating sine of x squared, you get a cosine in there. There's no cosine in the problem. That tells you made a bad choice. So if you make a bad choice, something's going to come up that tells you it's a bad choice. You have to heed its warning. Go back. But again, u equals x is never a thing for integration by substitution, ever. And you guys saw why, right? It's a learn by doing. Doesn't change the problem fundamentally. Okay, so we're ready to move on to the next integration by substitution topic. There's a lot in this section. Like I said, this is the only advanced technique of integration that we learn in AB. So it's our first in BC. All right, let's say we have this right here. The integral from 0 to 2 of x times the cube root of 4 plus x squared dx. All right, now I'm telling you, this is BC, and we should understand these things. If you do this, is that valid or invalid?
Invalid.
That's invalid. How many points do you think you're going to get for this problem? 0. Okay, you did nothing right. And that's a major transgression. Like, oh, I just took out the x. Yeah. The take it out property. All right. Here, we're going to look at all the things that tells us this is an integration by substitution problem. We have a product and there's no product rule. We have a composition also. And a fill in the blank sentence works. X is close enough to being the derivative of 4 plus x squared. So all those things right there say integration by substitution. But what's different about this problem than the others that we've done in this section? It's a definite integral. Don't knock your composition book over. Don't mess up your poems. All right, so we'll look at how to deal with that. We have u equal 4 plus x squared. du is 2x dx. I look at that and I say I don't have an x dx, I don't have a 2x dx, I have an x dx. So I'll multiply both sides by 1/2. All right, so that fits all of our experiences from Thursday and Friday, right? Now, I just intentionally made a mistake in that problem, in writing that line. What mistake did I make? Okay?
Are the values different because it's u instead of x?
Yes. All right, that 0 to 2 are values of what variable? X. We're doing a change of variables from x to u, and our change of variables needs to be complete, okay? So this right here is misuse of equality. We're saying two things are equal when they're not. So limits of integration, if you did this and let them as 0 to 2 and work the problem all the way through, that answer will be there. in the multiple choice problems, because this is the most common student mistake with definite integration by substitution. So the limits aren't 0 to 2. We have to figure out what they are. And obviously that doesn't involve guessing. All right, so Hank got the conversation going in the right direction. We need to finish it now.
We can substitute in 0 and 2 to the equation relating u and x.
Yes.
And solve for u.
All right, now this is important. And this is one thing, this is one of the things, because I can't get people to buy in, because obviously I don't know what I'm talking about. Just graduated college, trying to figure things out. Always write the upper limit on the upper line and the lower limit on the lower line so you don't accidentally reverse them. Okay? If x is 2, what's u equal to? 8. And if x is 0, u is 4. Okay? Your change of variables must be complete, and that includes the limits of integration. But then I get people, how come we didn't have to do that with the indefinite integrals? Because they don't have limits of integration. Okay? Now, see all this stuff up here? We're done with it. We don't need it anymore in this problem. We're not erasing it though. Harry just waved goodbye to it. Tender moment. 3/4 u to the 4/3, that's pretty easy to anti-differentiate. By changing the variables, we had no more product and no more composition. Our constant multiple rule. Eight to the 4/3 minus 4 to the 4/3 is not 4 to the 4/3. What's 8 to the 4/3? Quick. 8 to the 4/3. What's the simplest way to get that 16? Yes. Okay? People think that 8 to the 4/3 means raise 8 to the 4th and then take the cube root. Take the cube root first and then raise it to the 4th. Okay? Now, this is very important. People deal with this the wrong way all the time. They're like, oh, well, I can't take the cube root of 4, so I'll raise it to the 4th power. And then you get the cube root of, what is it? 256. We're going to get through this without doing that, though. Because then you'd have to figure out how to simplify the cube root of 256, which you're not going to do. Everybody agree those are the same? Actually, I'll go one step slower. For those of you who we generally don't use mixed numerals here, but that's a mixed numeral. Does look weird because we don't use them very often. All right, 1 1/3 is 1 plus 1/3. And it's, in its simplest form right away. We never had to do any crazy arithmetic. Craziest arithmetic we had to do was 4 divided by 3 is 1 1/3. That is a proper way to deal with something like that. Not by, oh, I can't cube root 4, so I'll raise it to the 4th power and then try to simplify it. We got a new student. All right, everybody